Okay, hello everyone. Welcome to our brief Intro to Advanced Math quick example for today. So I'm going to do one example that looks at one of the types of counterexamples that you could come up with, and maybe a thought process to help you come up with more counterexamples that deal with images and inverse images of functions. So here we have, find an example that shows f inverse of y does not equal y for some function that maps a to b and some y that's a subset of b. So basically what we're trying to show is that if you look at the inverse image, then look at the image of that, you don't always get back the original set. Now, for those who are comfortable with inverse functions, this should be true with inverse functions, but when it comes to images and inverse images, we know that the inverse image is not always an inverse function. It doesn't need to be well defined that way. So what I have up here is a decent example that you might be coming up with, because some of the benefits of counterexamples that we can come up with images and inverse images is that you can have two elements in our domain get mapped to the same element in the codomain. So this is usually a good way to come up with something, is if I can incorporate this into my picture here. So this might be your first thought of how could I find something here. So we have to define this as a function. I have my set A and my set B. To define this as a well-defined function, make sure that you have every element in the domain get mapped to something in the codomain. So let's say I map 1 over to A here. Okay, so now we have this example, so we have to find some set y that's a subset of the codomain B. So your thought might be, what if I take this to be my set y? Well, then if we want to see, does this work as a counterexample? Well, we have to first find what is the inverse image of my set y. So if I look at the inverse image of y, that's all of the elements in my domain that got mapped to elements in y. So we see that indeed we have the set containing 2 and 3. So this would be the set containing 2 and 3. Then I say, okay, what is the image of this set? So the image of this, so what this left-hand side this is going to be the image of the set containing 2 and 3. And when we find the image, we're trying to find what are all the elements in our codomain that get mapped to from elements over here. So we see that in this case, we see all the elements in here that get mapped to from 2 and 3 is just simply the set containing B. So this is the set containing B, which is equal to Y. Now, that is not what we want to show. We want to show that these are not equal to each other. So we have to come up with something else that's unique about functions that maybe we don't always think about that could be used as a nice part of our counterexample. So to just do a slight change here, what we can do is we could enlarge the set Y to include this. So when we think about good counterexamples or unique things about functions, remember every element in our domain has to be mapped to something in the codomain, but not every element in our codomain has to have something that gets mapped to it. So because of this, let's see what happens now if we can try to verify this for this case. So our y, this is now the set containing both the elements b and c. So if we look at the inverse image of y, well, that's just the same thing that we had last time because nothing gets mapped to c. So the only elements in our domain that get mapped to something in y, these are just simply the set containing 2 and 3. Then if we find the image of this set, then the image of 2, 3, that's all the elements in the codomain that get mapped to from our domain, well, indeed, we see that is simply the set containing B. But in this case, it is not. equal to y. So that's exactly the type of counterexample that we'd be looking at in this case, is trying to use the fact that not everything in the codomain has to have something mapped to it. Also notice that in this case, I didn't even need these elements. You could have done this perfectly fine without this. So sometimes it's nice to just simplify things and only include the elements that you need to be able to have the type of example you're looking at. So if you even slim this down further, the question is, could you do that? Could you make this an even smaller type of function? Well, yes, you could. You could also eliminate this element over here. So our domain just consists of one element. Our codomain consists of just two elements. In this case, we would just get rid of the element 3, and we have the same exact thing going on here. That the inverse image of y is now just the set containing 2. The image of the set containing 2 is just the set containing b that is not equal to our original set. This is the smallest type of counterexample that you could come up with. So when you're trying these on your own, don't try to create something with 50 different elements, try to create weird mappings. Just try to simplify things as small as you can. Hopefully that helps.